Hey everyone, welcome back to this Python series. My name is Ansh Patania and today we are going to learn two core concepts of Python, which is dictionaries and sets. So without wasting any time, let's get started.
Let's start with dictionaries. To understand what a dictionary is, think of your phone's contact lists. In your contact list, you don't search your friend by position numbers like contact at index 4. You look up their name to retrieve their phone number. In Python, we call this a key value pair. The key is the lookup term and the value is the data attached to it. Let's understand this with an example. Let me write a code first and then I'll explain the code. Let's create a basic dictionary. So now let me explain this code. Let's break down this code. So I've made a dictionary. I've made a dictionary on line second. Product on line first, product is equals to, I've done curly braces tells that we are defining a dictionary. And the keys here is ID, title, price, in stock and color. Keys are on the left side of the column. They act as unique identifiers for each piece of data. Values are on the right side. ID colon 101 is the value. Wireless headset is the value. 49.99 is the value. True is the value. And the list I've made is the value. Values are on the right side. Now commas. Every key pair is separated by a comma. Forgetting a comma between pair is one of the most common syntax error for beginners. And the type product I have written at the very end running type on these variable on this variable output class dict here. Class dict. Confirming Python recognize it as a dictionary object. Now duplicate key behavior. Let me explain you this with an example. User is equals to, we're going to make a dictionary again. Username coder 123. Username Python XYZ. Let's print user. Oh, I've done the same mistake. I forgot the comma here. No. Why did coder123 disappear? Dictionaries in Python cannot have duplicate keys. Python evaluates dictionaries definitions from left to right. When it processes the first username key, it assigns the value coder123. But when it hits the second username key, it doesn't throw an error. It simply overrides the previous value with Python XYZ, as you can see here in the output. If you ever notices data unexpectedly disappearing from a dictionary, check if you accidentally reused the same key name. Now let's understand how to access, modify, and how to nest the data. How do we pull data out of a dictionary? We do that by modifying existing values or add new ones. Let's take a look now. Student is equals to, first we are going to make a dictionary name Araf. Oh, GPA, that's right, 3.8. Is enrolled. True. Print student name. Print student GPA is equals to 3.9. Student city is equals to Mumbai. Let's print student. Now accessing student name here. We pass the key inside square brackets. Python look up name directly and returns rf here. As you can see, this lookup is extremely fast. It takes constant time regardless of how large the dictionary is. Now updating here. Student GPA is equals to 3.9. Since GPA already exists inside the dictionary, as you can see here, 3.8. Python overwrites its old value 3.8 with the new value 3.9, as you can see in the output. Now the new GPA is 3.9. Now adding students square bracket city is equals to Mumbai. Since city does not currently exist in the student, as you can see here, but Python creates a brand new key city and attaches Mumbai to it, as you can see in the output here. Now mutability. Unlike strings or tuples, dictionaries are mutable. You can modify their contents directly without creating a new dictionary variable. Now removing key. We can use del and pop. Let's understand with this example. Del is equals to del students. Oh, we can do that on the same example. Now let's comment this out. Del student is enrolled. Remove city is equals to student dot pop city. Print removed city, comma removed city. Let's run our code. Here is the 11th line. Remove city. Oh, there is an error. Let's comment out this. There is an error. It is showing an error. Now it will work. Now del student is enrolled. The first line we have written here. Let's give some space here. Yep. Here del student square brackets is enrolled. The del keyword completely deletes the is enrolled key and its value from its memory. It does not return anything. As you can see here, it has removed the is enrolled here. Name Arav. There is only name and GPA in the output. Now student.popCity, here we have used pop. The pop method removes the key city, but unlike del, it returns the removed value Mumbai. This lets you store the removed item in a variable removed city for later use. Now, if you try to run del or pop on the key that does not exist in the dictionary, Python will raise a key error and crash your code. Now let's understand what is a nested dictionary. Let's first write a code. School is equals to, let's make a dictionary first. Student name Priya. Marks maths 92. Science 95. We have to add comma here. Name maths. Wait a minute, I've missed something here. This Let's printer nested. Let's run our code. In the output you can see here Priya and 95. Now first let's understand what is nesting here. Nesting means placing one container inside another. Here school is an outer dictionary. This is an outer dictionary, school. Here, whose values are themselves dictionaries. Student underscore 1 and student underscore 2. Inside student 1, the marks key contains yet another dictionary. Now chaining square brackets. Here, school student 1 extracts the inner dictionary from Ria. School student 1 marks extracts the marks dictionary. Maths colon 92, science colon 95, and the school student 1 marks and science digs down to extract the specific integer 95, which is the output here. Now that's why we got Priya 95. Here we extracted the student from student 1 dictionary. Student 1, the name here, the name is Priya, and in the second line we've extracted student 1. This is student 1. We have extracted marks. This is marks, and in marks we want to know the marks of subject science. Now this is how you have to write the syntax of your code for nested dictionaries. Now Python provides, now let's talk about essential dictionary methods. Python provides 5 built-in methods that make working with dictionaries fast and convenient. Let's inspect each one. Let's write a code. Data is equals to, let's make a dictionary first. A 10, comma B 20, comma C 30. Let's print code data dot keys, print list data dot key, print list data dot values, print list data dot items. Let's run our code. Now and a dict keys and view objects. Calling data.keys doesn't return a standard Python list. It returns a special object called a dict view. The view is dynamically linked to the dictionary. Means if the dictionary changes, the view updates automatically. Now, typecasting with list, because dict views don't support the traditional indexing. Example, data.keys square bracket 0 causes an error. We wrap them inside lists whenever we need a standard list of items. Dot item returns each key value pair formatted as tuple. Key comma value. This method is useful when iterating through a dictionary using for loops. Now let's talk about the dot get method. Let's write our code. Here the output, as you can see here, we are accessing name here. What is the name? Siddharth. If we run this code, the output will be Siddharth, and print user.get name. The output is same. Now let's make another case 2, print user.get email. Print user.get email, comma, not found. Let's run our code. Here, as you can see, first let me summarize the code. The direct square here in the the direct square. If email doesn't exist, Python panics and throws a runtime error called key error. The .get advantage is .get email gracefully returns none instead of throwing an error when a key is missing. There is an error here, attribute error. First, there is this mistake. Yeah, now it will work. Now the .get advantage is you will gracefully get a none value here instead of throwing an error. It will not throw an error even if the email doesn't exist. The .get fallback parameters .get email comma not found here. You can pass a second argument to .get if the key is missing. Python will return that custom fallback string instead of none. Best practices: use square brackets when you want your program to crash. If expected data is missing, use .get when data might optional. Now merging with update, let's understand the update method here. Let's make another dictionary. User profile is equals to name Ananya. Age 28. Now let's make another dictionary. Age 25. Country India. User profile dot update. New data. Print user profile. Let's run our code. Now how update works. It takes a second dictionary, new data. This is the second dictionary, new data, and merge it directly into the original dictionary called user profile. Existing keys like age here, because age already existed in user profile here and here. Its value was updated from 28 to 25. Let's change here. Let's do this 29. The age is decreasing here. Yep. Now its value was updated from 28 to 29. Now we have added a new key. We have updated a new key here, because country was not in user profile. It was added as a new key value pair here. Country India. In place modification, update modify user profile directly and returns none. Do not write user profile is equals to user profile dot update, or your variable will become none. Now I've told you the basics of dictionaries, the syntax, and the built-in dictionary methods. Now let's move to sets. Firstly, sets are immutable elements. A set in Python is an unordered collection where every single element must be unique. First, let me write a code. Let's create a set first. How to create a set? Wait. Number is equals to 1, 2, 3, 4, 5, 6, 6, print numbers, print type number. Let's run our code. Yep. As you can see here, let's get the length of this set. Now as you can see here, sets have some some properties. First is automatic deduplication. Even though we wrote 6 3 times here, the set instantly discards the duplicate upon creation, leaving only 1, 2, 3, 4, 5, 6. The second one is unordered nature. Set do not preserve the order in which items are added. You cannot access elements using indices like number in square bracket 0. You cannot access that. Doing so will throw a type error. Now here we have written length. Here we have used len function. Len has returned 6 because Python counts only the unique numbers, distinct elements stored in the set. Let's write our code first, and then I'll explain the empty set trap. Let's run our code. Here it shows it is a class dict. Why does curly braces default to a dictionary? In early version of Python, dictionaries were introduced before sets. Because both use curly braces, Python defaults curly braces to an empty dictionary for backward compatibility. The rule: if you want an empty dictionary, use curly braces. If you want an empty set, you must call set. Let me show you how to do that. Empty set print type empty var. Let's run our code. Here, as you can see in the output, the first one, the curly braces, it shows the output is class dict. And if you want a empty set, you have to write this set and the braces. Now let's move to set methods and mathematical operations. Let's look at how we add, remove and perform mathematical operations on sets. Let's write a code. S is equals to set. First, let's make an empty set here. Now, adding elements. Adding elements. S dot add 10. S dot add 20. S dot add 20, or you can say 30. Let's run our code here. Oh, my bad guys, we have to print also. Yep. Now, as you can see here, it has added 10, 20, 30 in the set. Now let's try to add a duplicate value. Here let's add 20 again. Let's see it will print or not. Here, as you can see, it will ignore silently the duplicate value here. I've tried to add the 20 again, but it will ignore the 20. Now let's start removing the values. s dot remove 10, s dot remove s dot discard 99. Let's run our code. Oh, we have to print also. Printf. Now let's run our code. Here, as you can see, first let's talk about s.add. It tries to add 20 a second time. Python checks if 20 exists, sees that it does, and ignores the command without throwing an error. Now let's talk about dot remove versus dot discard. This is a crucial distinction. Use dot remove when you want your program to crash if X is unexpectedly missing from the set, and use dot discard when you want to silently ignore missing items without raising an error. As you can see, we don't have 99 in the set. We don't have 99 in the set, so it just ignored the command, and it is running perfectly. Now let's understand union, interaction, and difference. Let's write our code first, and then I'll explain you guys the concept of union, intersection and difference. Set is equals to 1, 2, 3, 4. Oh, this is not the right way to, 1, 2, 3, 4, 5, 6, 7, 8, 6. Set B. Let's do one thing. Here remove, let's go till 4 is equals to 3, 4, 5, 6. Print set A dot union set B. Print set A dot enter action set B. And set A dot difference set B. Let's run our code. There is a intersection. There is a spelling error here. Yep. Now let's first let's talk about union. A union B combines all unique items from both sets. The overlapping values 3 and 4. As you can see, in the set A we have 1, 2, 3 and 4, and in the set B we have 3, 4, 5, 6. The common values, the overlapping values, are 3 and 4. It will the 3 and 4, it will include only ones. You can also write this using the pipe operator. Set A underscore set A and this one, this operator. Yeah. You can do this by using this operator. And now let's talk about intersection. A intersection B identifies the common elements shared by both sets. Here only 3 and 4 exists in both set A and set B. You can also use the ampersand operator set A and set B. Now the difference here is, now let's talk about difference here. Take set A and subtract any element that also appear in set B. Since 3 and 4 are in set B, they are stripped out, leaving 1 and 2. You can also use the minus operator here for doing difference, for doing the difference, and the intersection, not interaction. I'm saying interaction always. Intersection, you can use AND operator, and for the union you can use OR operator. Let me write here. Use this one, OR operator, you can use AND operator, and here you can use minus. Yep, you can use minus operator. Now it's time to put everything we learned to the test. Try solving each problem on your own before walking through the explanation with me. Okay, so now let's solve some practice problems here. We have 4 practice problems. The first one is word meaning lookup engine. The second one is unique subject and room calculator. The third one is numeric type ambiguity, and the fourth one is multi-day web visitor analysis. Now let's start with the first problem here. Word meaning lookup engine. So first I'll write the code, and then later I'll explain it. So first we'll make a dictionary. Let's name it dict is equals to dict1 is equals to table piece of furniture with a flat top and one or more legs. Second key will be cat, a small domestic carnivorous animal. Don't forget to add column at the end. Python, a high level. Comma, general. Purpose programming language. This is our dictionary. Now Our second step will be normalizing the user input. We will take input of query. What is the query here? Input enter a word to look up. Let's strip this. We'll use the chaining method. We'll strip this and we want all of this in the lower cases. We'll convert into lower cases. And our step 3 will be using get function here, get method, so that if the key does not exist, it will not throw an error. It will just write none. It will give the input none. So meaning dict1 dot get query comma word not found in dict. Let's print the output here. Let's add we'll use f string here. Let's add a space. Result for query meaning. Okay, so now let's run our code and then I'll explain you. Let's enter a word cat. Now result for cat, a small domesticated carnivorous animal. Let's write a word which is not in the dictionary. Let's write cap. Result for cap, word not found in the dictionary. So our code is running properly. Now I'll explain why this code works under the hood. The first is key value indexing. The dictionary maps string keys to their corresponding definitions. Lookup via hash evaluation rather than scanning through item one by one. And the second one is input normalization. As here we have used input normalization strip method, and the lower method removes the leading accidental white spaces, and while lower converts the input to lowercase. This prevents simple casing mismatches failure like Python versus Python. We are writing Python versus Python means we are writing in. Let's run our code. I'll show you. Let's write Python in small letters first. Let's enter this. As you can see, a high level, our output is there. Now let's write Python in capital letters. Python. It has given the same result to us because of this lower method here. And the third reason why this works is .get. Here we have used .get. Using standard square brackets, dictionary square brackets query on a missing key raises a runtime error called key error. The .get method acts as a built-in guard, as I've told you before. Built-in guard. If the key exists, it returns the string definition. If it doesn't exist, it safely returns our fallback string, word not found in the dictionary. As I've told you, if we enter cap here, the output is word not found in the dictionary. So our first code is done. We'll move to our second problem. What is the second problem here? Second problem is unique subject and room calculator. Extract duplicate course requests from a list and calculate required room allocation using set duplication. So first I'll write the code here and then I explain it. First we will make a list here. Now first we made a raw list containing duplicate enrollments. Duplicate one is Python, C++, Java, all are duplicates. Now our second step will be converting the list to a set. Now how to convert a list to a set? We are going to use set function. Unique subjects is equals to set raw enrollment. This is the second step. We have converted the list into set. Our second step will be counting the unique subjects. Now how we can count the unique subjects? We are going to use len function here. And at the end we'll print our output. Here we are using f string. Let's run the code. Now I'll explain you why this works. This works because of first reason. The first reason is instant deduplication. Passing a list into set, as you can see here, we've passed a list into a set, triggers Python's hashing mechanism across all elements. Duplicate values are discarded automatically in a single step without needing a for loop or if statement. And the second reason is length evaluation. Here we have used len function. Calling len function on the resulting set yields the exact number of unique items left, representing the total number of physical classrooms required. As you can see here, first we have printed raw registration list. Here is the raw registration list: Python, Java, C++, Python, JavaScript, Java, C++. Deduplicated course set is Java, C++, Python and JavaScript. And at the end, total classrooms needed. We need 4 classrooms. It has removed all the duplicates. It has deduplicated the course set, and at the end it is given the total classroom needed. So now let's move to the next problem number 3. Numeric type ambiguity 9 versus 9.0. Python evaluates 9 is equals to, this is a comparison operator here. This is a comparison operator. This is comparing 9 and 9.0 as true, causing set to merge them. Differentiate them using type tuples. Here we have to use tuples. Yep, here we have to use tuples, I think so. Let's first, I'll write the code and then I'll explain you. Standard set is equals to 9, 9. Print f standard set output standard set. Here we have set the standard set behavior, which evaluates 9, which compares 9 to 9.0 as true, and the second step is the preserving type distinction using tuples. We are going to use tuple here. Type set is equals to int 9, comma float 9.0. Let's print the final typed set output typed set. here, as you can see. Now I'll explain you why this works. The first reason is value equality collision. Python checks values equality across numeric types. 9 is we are using here comparison operator, double equals to 9.0 evaluates to true, and both shares the same integer. As a result, standard set treats 9.0 as a duplicate of 9 and collapses them into a single entry 9. The second reason is type tuple solution here. Tuples are immutable and hashable, making them valid set elements by pairing the type name with the value. Example, here we have used int comma 9 and float comma 9.0. The hash calculated for each tuple becomes completely distinct, allowing both entries to coexist peacefully in the set. Here both are coexisting, as you can see in the output. Our standard set output is 9 because as a result standard set treats 9.0 and 9 equally. It will collapse them into a single entry, and the typed set output is this float 9.0 and int 9. Now let's move to our next problem here. The final problem is fourth one. Multi-day web visitor analytics. Compute total unique traffic and returning user across multiple days using set mathematics. Now let's start our code. Day one visitors. User 101 to user 102 to user 103 to user 104. Let's copy the first one. 103, 104, 105 and 106. It is storing visitors IDs as set for each operational day. Now we are moving to the second step here, total reach. We are going to use union here, the or operator. Total reach. Now total reach is day 1, day 2, day 1 visitors and day 2 visitors. Now third step is returning users. Returning users retention, here we are going to use AND operator. Returning is equals to day 1 and day 2. Now our fourth step is new day 2 acquisitions. Here we are going to calculate, in simple words here we are going to calculate difference. We are going to use minus sign, minus operator here. New day 2 is equals to day 2 minus day 1. Here we are calculating the difference. Now let's print our final output. Total unique reach. Here we are going to use len function because we have to calculate the total unique reach. Total reach user total reach. Now we are going to print the returning user retention. User returning. Let's print the final value here, new day 2 acquisition. New day 2. Len new day 2. User new day 2. Let's run our code. Yeah, so it's running. Yeah. Now I'll explain the code. Here first we've made two sets here, day 1 and day 2. Day 1 visitors and day 2 visitors, they have unique IDs, and the second step is to find the total reach. If we have to find the total reach, we are going to use the union here, and the third step is the returning users. For returning users, we are going to use intersection, and our fourth step is to find new day 2 acquisitions. Here we have to find the difference, so we are going to use minus sign. And at last we have printed the final answer. Now why this works? First is union operator combines every element from both sets while stripping out overlaps, calculating the total unique audience reached across all days. Second, intersection operator isolates only elements that exist in both sets, simultaneously gives you your returning retention count in a single step. And a third reason is difference operator, at last we have used, subtracts all the elements of day 1 visitors from day 2, leaving only brand new users acquired on day 2. So we have solved all 4 practice questions. You can find more questions on ChatGPT or Google. So yep, that's it for today's video. This wraps up our chapter number 4. Today we transformed how our application handles memory and data modeling. We moved past positional index numbers and learned how to build high-speed key values lookups using dictionaries, protects our code with safe access tools like .get, and performs instant deduplication and set maths with sets. And remember the fundamental rule: use dictionaries when your data needs context and labeled relationships, and use sets when you need uniqueness, set comparisons, and fast membership testing. So that's it for today's video. Thank you for watching.